Hello and welcome to Ruby tutorial. In this video, we will talk about Ruby operators. We will discuss different types of Ruby operators, and then we will see what are the operators in each type, how they work, and how we can use them in a Ruby program with some real examples. So the first type which we will discuss is arithmetic operators. These operators help us to perform mathematical operations in a Ruby program. For example, if we want to perform addition, subtraction, multiplication, or division, we use these operators. Next type is comparison. As we can guess from the name, these operators help us to compare values. For example, if we have two numbers and we want to check if one number is equal, greater, or smaller than the other, then we use these operators. Next type is assignment. With the help of assignment operators, we can assign values to the variable. In assignment, we have a special type parallel. With the help of parallel assignment operator, we can assign values to multiple variables in a single expression, or we can say on a single line of code. The next type is logical operators. Logical operators are used to combine two or more conditions. So for example, if we have two comparison operations and we want to combine them, then we can use a logical operator. So if we look at an example, let's say we have three numbers A, B, and C, and we want to check if A is equal to B and A is equal to C. So this is how we write, and here AND is a logical operator. Next type is ternary operator. Ternary operator is represented like it's mentioned in the brackets with the question mark and a colon. And a ternary operator actually has two parts, like we can see here. So one part is on the left side of question mark and one side is on the right side of the question mark. The part on the left side of question mark is an evaluation expression which is evaluated to true or false. And on the right side are two different statements. So statement 1 on the left side of the colon and statement 2 on the right side of colon. And on the basis of result from the left side of question mark, the statement 1 or statement 2 is executed. So let's say if the result of evaluation expression which is on the left side of question mark, if result is true, then the statement S1 will be executed, and if the result is false, then the statement S2 will be executed. So we will see this later with a real example, and then you will have a better understanding how it works. The next type is range operator. Range operator help us to create a particular sequence range of elements. So for example, if we want to generate a range of number from 1 to 10 or 1 to 100, then we use these range operators. Next type is defined. Defined operator help us to check if a variable or a function is defined in a Ruby program or not. So if you are writing a program and you try to use a variable or a function which is not defined, then you will get an error and your program will not continue its execution. And to avoid this, we use this operator to check where we are not sure that if a variable is defined or not. This operator help us to check. The next type is this dot and this scope resolution operator. Scope resolution is represented with this double colon. So at the moment you can just remember that these are two operators, how they work and how we use them. This we will see when we will discuss classes and objects and module. The next type is bitwise operators. Bitwise operators work directly on binary representation. So for example, if we have a number and we want to perform some operations directly on the binary representation of this number, then we use bitwise operators. So now to see some real examples and to see what are the different operators in each type and how they work, I will start IRB. IRB stands for Interactive Ruby. The first type which we will explore is arithmetic operators. Like I mentioned before, arithmetic operators help us to perform mathematical operations in a Ruby program. So if we want to perform addition, then we will use the symbol plus. And now if I want to apply addition on 4 and 2, then we will write it like this, and I will press enter, and we will see that we have result 6. Similarly, if we want to perform subtraction, then we use this symbol dash, and now this is 4 minus 2 and we know result is 2. If we want to apply perform multiplication, then we use this asterisk symbol, and now if I press enter, we will see the result is 8. Similarly, we can perform division. Division is done using this forward slash symbol. And now if I press enter, you will see the result is 2. Besides these basic operators, we have two more special operators in arithmetic operators. One is modulus operator. Modulus operator is presented by this symbol. What it does, it returns us the remainder from a division. So for example, if now we are dividing 4 with 2, these are completely divisible and the remainder is 0. So if I press enter, we will see the result is 0. But if I divide 4 with 3, then we know that it's not completely divisible. So 3 ones are 3, and then if we take out 3 from 4, then the remainder is 1. And now if I press enter, we know that the result here is 1. The last operator is exponent operator, and exponent operator is represented by double steric symbol. And if we want to calculate the power or exponential calculation, then we use this operator. So now, for example, if I want to calculate 4 power 2, then this is how I will write in my Ruby code. Now if I press enter, I will say 16. So 4 into 4 is 16. So these are all the arithmetic operators. The next type which we will explore is comparison operators. Like I mentioned before, comparison operators help us to compare values. So for example, if we want to compare a number 4 with another number, let's say 3, then this is how we write. If you notice here, we have used two equal symbols. So these two equal symbols together represent one operator, which is equality check operator. So now we are checking that if these two numbers are equal. If I press enter, we will see result is false because these two numbers are not equal. If I replace 3 with 4 and check again, now we see the result is true. Similarly, we can check if two numbers are not equal, and this inequality is done using this operator, which is exclamation mark together with equal symbol. And now if I press enter, we see result is false because we are checking if 4 is not equal to 4, and this is false because 4 is equal to 4. If we replace this 4 with 3 and check again, now the result is true. Similarly, we can check if one number is smaller than another number, and this is done using this symbol. So now if we say that we want to check if 4 is less than 5 and it's true, when we press enter, we will see the result is true. And if we replace 4 with 4, now we are checking if 4 is less than 4. So this result is false now because 4 is equal 4 in this case, so it's not less. And when we press enter, we see the result is false. And similarly, if we replace 4 with 3, then this is also false because 4 is not smaller than 3. Similarly, we can check now if one number is greater than other. So this symbol is used to check if a number is greater than the other one. And let's say if we want to check 4 is greater than 3, and then if I press enter, the result is true because 4 is greater than 3. If I replace now 3 with 5 and check again, now we have result false because 4 is not greater than 5. Now we can combine this greater than symbol together with equal symbol, and this means that we are checking two things in one expression. So now when we write an operator like this, it means that we want to check if 4 is less than or equal to the number which we will write on the right side. So let's say if I want to check if 4 is less than or equal to 3, this is how I will write, and when I press enter, we will see the result is false because 4 is neither small nor equal to 3. But if I replace this 3 now with 4, you will see the result is true because one condition is false, that 4 is not smaller than 4, but the other condition is true, that 4 is equal to 4. And similarly, if I replace now 4 with 5, now one condition that 4 is less than 5 is true, so we will again have true result. And similarly, if we want to check if one number is greater than or equal to the other, then this is how we do it. So we, if we want to check 4 is greater than or equal to 5, so then this is how we will write, and if I press enter, I will see the result is false because 4 is neither greater nor equal to 5. And this is how you can perform this greater than equality and greater than equal to check. Then we can combine all these symbols together. For example, we can write something like this, and this means now we are checking if a number is less than, equal, or greater than the other. And what we get from this operator is this operator returns us three values, so 0, 1, or -1. So if two numbers are equal, then we get 0. If number on the left side is smaller than the number on the right side, then we get -1. And if number on the left side is greater than the number on the right side, then we get 1. Similarly, we have another function here which is EQL with the question mark, and this also helps us to check the equality. And what it does is it actually check two things. So one thing it check is the value, and second the type of the number. So here if you look, the first number 4 is an integer number, and the second number 4 is a decimal number. And now when we are comparing these numbers, we know the value is same. Both numbers are 4, but the type is different. And now if I press enter, I will see the result is false because the type is not matching. But if I replace this 0 and point, and now we know that both numbers are same and the type is also same, and if you press enter, you will see the result is true. Beside this, we have triple equality symbol as well. So triple equality symbol actually is used on a range. For example, if you have generated a range from 1 to 10, which we will see later as well. So this double dot is a range operator, and if we want to check that there is a number 5 in this range, then we check this with triple equal operator. And when we generate a sequence of number from 1 to 10, then of course 5 is in this range, and when we will press enter, we will see the result is true. But now if I replace this 5 with 11, and now we know that in the range from 1 to 10, 11 is not in there, and when I press enter, I will see the result is false. The next type which we will explore is logical operators. Like I mentioned before, these operators are used to combine two or more conditions. So for example, we have a condition 2 is equal to 2, and we want to combine it with another condition, and we want to use the logical operator AND. So we will write and the other condition is 2 is less than 3. So the important thing to note about logical operator AND is that the both side of the AND operator should be true to get a true result. So in this case, 2 is equal to 2 is true, 2 is less than 3 is true. So now when we will press enter, we will see that we have true result. But if one side, for example, is not true, then we will always get a false result. This same AND can be used with the this symbol. So if we write this AND symbol two times, it also represent logical operator and this second expression what we wrote now with this symbol is exactly similar to this expression. So you can either use the word AND or you can use this symbol two times. And now if I press enter, we will see that we have a same result here. The next logical operator is OR. So if we want to combine again two conditions, 2 is equal to 2 or 2 is less than 3. So this is how we write a OR logical operation. For the OR, important thing to remember is that one of the side should be true to get a true result. So if both sides are false, we will have false. But if one side is true, doesn't matter if the left side or the right side, then we will have a true result. So in this case, 2 is equal to 2 is true, 2 is less than 3, this is true, so both are true and we will have a true result. But if now I say 2 is equal to 2 is true and 2 less than 1, this is now false. Again, we will have a true result because OR operator need only one side to be true. But if we want a false result from OR, then both sides should be false. So now both sides are false, and when we press enter, we will see we have a false result. And the last logical operator is not. What not does is it is represented with this symbol and it reverses the logical state of its operand. So let's say here we have an operand true, and when we will press enter, we will see that this true is converted to false now. And similarly, you can use other expressions. So for example, here 2 is equal to 2 is correct. And now if we apply not logical operator on this, then this true will be converted to false and we will have the false result. One last thing about logical operators is that you can combine more than two conditions, and you can combine these and, or, and not all together. So for example, if we want to use all these logical operators together in one statement, we can do that. So for example, if we want to check 2 is equal to 2 and 2 is less than 1, or 2 is equal to 2 and 2 is less than 5. So when you write multiple conditions together, then you need to use brackets to define the scope, that how they are connected. So for example, if I want to connect this and then I want to use the OR on the evaluation of this, then this is how I can combine them. So what is happening now is that first the AND logical operator will be used on these two conditions, and there will be a result true or false from this complete statement. Then an other AND operation will be used on this statement, and we will have a Boolean result from this side. And then the result from this side and result from this side will be evaluated with the logical operator OR. So now if we try to make a dry run, we will see that 2 is equal to 2 is true, 2 is less than 1 is false. So altogether this statement is false. And if we check this, 2 is equal to 2 is true and 2 is less than 5, this is true as well. So this side is true now, but this side is false, and we are using an OR logical operator in between, so we know that OR need only one side to be true. So this side is true and we will get the end result true here. And similarly, if we use AND here, for example, and we replace this with OR, and now we try to make a dry run, we will see that this 2 is equal to 2 is correct. So we don't care about the second one because we are using the OR logical operator. So this whole statement is true. And here 2 is equal to 2 and 2 is less than 5. So this side is true and this side is true as well. So AND need both sides to be true. And at the end we have true from this as well. So both sides are true, and then the final AND will also result in true. So the end result is true here. The next type which we will explore now is assignment operators. Assignment operators are used to assign values to variables. So for example, if we want to define a variable x and we want to assign a value 5 to this, then this is how we will write. So what we are doing now is we are using an assignment operator equal, and we have defined a variable x and we are assigning a constant value 5 to this x. So now when we press enter, we have defined a variable x with the value 5. We can use puts to print the value of x, and when we press enter, we will see that we have on this line answer 5. 5 is the value which we stored in x. So now this is the assignment operator, and it can be combined with other arithmetic operators using assignment operator, which is this incremental operator. What incremental operator does is that we know that the current value of x is 5, and when we say plus is equal to 2, then it's equal to x is equal to x plus 2. So now when we will press enter, we will see the result is 7. And similarly, if we want to subtract, this is decremental operator, minus together with equal, and in this way we can subtract a value 2 from x. So this is actually exactly the same like we write x is equal to x minus 2. These two expressions, for example, this or this, are exactly the same. And similarly, like plus minus, we can also use multiplication. We will now with this expression multiply the value of x with 2. So current value of x is 5. And when we will multiply it with 2, we know the result is 10. And in same way, we can use the division operator. Now what we are doing with this assignment operator, we are dividing x by 2. X is 10 divided by 2. Again, we have the result 5 now. Similarly, we can use the modulus arithmetic operator with assignment operator together. And if we divide 5 by 2, we know the remainder is 1. So the result is 1 here. And now the last one is exponent operator. So if we say we want to calculate the power, so x is 1 now, and doesn't matter what we pass here, 1 power 20 is 1. So no matter what we give as a power. But if we change the value of x to 2 again, and now if we calculate the power, so now 2 power 20 is this number. So these are all the assignment operators. Next type is ternary operator. Ternary operator, like I showed you before, is mentioned using a question mark and a colon, and it has two parts. So first part is an evaluation expression. For example, we have an expression 2 is equal to 2, then we have a question mark, and then we have two statements on the right side of question mark. So for example, first statement, we say we have a string 2 is equal to 2 is true, and second we say not true. So now what is happening here, that first this part will be executed to check if it's true or false, and we know that 2 is equal to true is true, and then this part will be executed, and here is just a string true, and it will be printed. But if this part is false, then the second part, which is after colon, this will be executed. So now if we press enter, we will see that we have a result true here. But if I replace this 2 with 3, for example, now we know that this evaluation expression results in false. So when this is false, then the second part, which is after colon, will be executed, and we will have a result not true. So this is how a ternary operator works. So now you can make it even more advanced. For example, if you want to define a variable x, and then you want to assign it a value on the basis of a condition. And what is your condition? So let's say you have marks, and the marks, we have to define this variable actually as well. So let's say you have marks in an exam, and the marks are 51 out of 100, and then we want to say that if marks are greater than 50, then we want to assign that the course is passed, and if the marks are less than 50, then it's failed. So now if we see here, the marks are 51, so these are greater than 50, and the result here is passed. But now if we change the value of marks to 40, for example, less than 50, and then we execute the same expression again, we will see the result is failed. The next type is range operators. Range operators are actually used in Ruby to create a range of successive values. How we do that? So let's say if we want to generate a range 1 to 10, and this double dots which we used here is the range operator, and when we press enter we see that we have generated a range now. This these two dots are presenting a range, and this range is now the numbers from 1 to 10. If we put brackets around this range and we convert it to an array, then we will see that actually we have all the numbers from 1 to 10. Now this range operator, if you observe, it has also included the both numbers, the starting number and the end number, which is 1 and 10. But if we want to exclude the last number, for example, we want to generate a range from 1 to 9, then we can use 3 dots instead of 2 to exclude the last or the end number. So now when I will press enter, we will see that we have numbers from 1 to 9. This is how range operator work. The next operator is the defined operator. Defined operator is used to check if a variable or a function is defined in a Ruby program or not. So let's say, for example, we want to use a variable age, and let's just print the value of age. And we know that we have not defined age variable, and when I will press enter, we will get an error because age is not defined. And if we assign a value to age, for example 20, and then I try to print the value again with puts, then we will see that the program executed successfully and we have the result 20 on this line. And in this case, when we want to use a variable and we are not sure if it's defined or not, then we use this operator defined, and we pass the name of the variable or the function to check if it's defined or not. And now when we checked, the result is local variable, so it is defined, it is a local variable. But if I replace age with name, for example, another variable, and now we know that name is not defined, and here you will see the result is nil, that this variable is not defined. Next type is dot and scope resolution operator. Dot operator actually we used already when we generated a range from 1 to 10. And what we did is we used dot operator to convert this range to an array. So this is how a dot operator work. We have a range in this brackets, and then this is our dot operator, and then we are converting this range into an array. And now when I will press enter, we will see that we have an array from 1 to 10. Similarly, we can use dot operator in many other cases. So for example, if I have a string, let's say name, and I want to convert this string to a uppercase string, then I use dot operator and I will call a function uppercase. I press enter and then I have a string in uppercase. So this dot operator can be used in many cases. So for example, whenever we want to access any function on a class, we use this dot operator. What we are actually doing here is also this is a string class. So for example, just for a little more information, if we call class on this, then we will see that the type of this thing, what is in double quotes, is string. And what we are doing is that we are calling a method uppercase on this class with the help of this dot operator, and then the method name is uppercase, which is converting all the letters in this string to uppercase. And we have also this scope resolution operator, which is presented with this double colon, and scope resolution operator is used to resolve the scope. This we will discuss when we will explore classes and modules. Next and the last type is bitwise operators. Bitwise operators work directly on the binary representation of integers in memory. So if we want to see a binary representation of a number, so let's say we have a number 18, and if we want to see the binary representation, then we will convert this number to string using dot operator and the function 2 underscore s, and we will pass a param 2. And now when we press enter, we will see that the binary representation of 18 is 10010. Similarly, if we want to see the binary representation of 20, we will press enter and see this is the binary representation of 20. Now the first bitwise operator which we will explore is and how we use this, we have a number 18, we will use symbol and the second number 20, and this is how we can perform bitwise AND on this operator. So now here you see the result is 16, and if we convert this result to string as well with by passing 2, and then we can see what happened is that the binary representation of 18 is this, the binary representation of 20 is this, and then this bitwise AND operator is applied on these two binary numbers. So let's see, the first bit of 18 is 0, the first bit of 20 is 0, and 0, when we apply the AND operator on both zeros, we have 0 here. And the next, here we have 1 and 0, again when we apply AND bitwise, then we have 0 again, because for AND I told you before that both sides should be true, and in this case when we are applying this on binary representation, then both sides should be 1. So here you see for all first 4 bits we have 0, but for this we have on both sides 1, so the result is 1. The next bitwise operator is OR. We will clear the console and print the binary representation of 18 and 20 again for the better understanding. And how we apply bitwise OR is using this pipe or line symbol. So now when I press enter, we have applied bitwise OR on 18 and 20. And now if we explore this for OR operator, I told you before that one side should be true to get true. So now in this case of binary representation, one side should have 1 to get 1 in result. So here if we see, we have 0, 0, result is 0, but the next in 18 we have 1, in 20 we have 0, result is 1, because OR need only one side to have 1. So similarly, next we have 0, 1, 1, 0, 0, 0, and 1, 1, 1. The next bitwise operator is XOR. XOR operator is applied using hat symbol. So this is the symbol which we use to apply XOR. The bitwise XOR operator performs what's called an exclusive OR operation on two binary representation. So what does that mean is if we press enter and see the result, then we will see the result here is 0, 0, 0, 1, 0, 1. So in case of OR operator also, when one bit is 1, we have 1. So here also 0, 1, 1. But what interesting to see is that there there are two ones, but in case of XOR, the result is 0 again. That's why 0, 0 is 0 and 1, 1 is 0. So these two zeros at the end here are not printed. So only the result of these first 3 bits is printed here. So in case of OR operator, when we used this line symbol or the pipe symbol, then this 1, 1 would have true or was true as well. But in case of XOR, it's true only when only one side is true. So if both sides are 0 or both sides are 1, it evaluates to 0. The next and last operator of binary operators is left and right shift. So let's say we again have number 18 and the binary representation is 10010. And now if we want to shift the binary representation of 18 to left, then we will use less than sign 2 times, and then we will pass the number for how much we want to shift this. So for example, if we want to shift it 1 time to the left, then we will provide 1 here, and when we press enter we see that before there were 5 bits in the binary representation of 18, and now we have 1 extra 0 here on the right side, and this number is shifted 1 time to the left. So now if we want to shift it, for example, 2 times or by 2, then we will pass 2 here, and then we will see that the original representation is 5 bits, but now we have 7, and we have added 2 extra zeros on the right side to shift it left. And similarly, if you want to shift it right, then this less than symbol will be changed with the greater than, and then we will shift it 1 bit to the right. So before we had 5 bits here, and now we shifted it right and we have 4 bits, so we removed 1 0 from the right. And similarly, if we want to shift 2 bits to the right, then we pass the number 2, we press enter, and we see that now we are left with 3 bits, and we removed 2 bits from the right, and we shifted the binary representation by 2 to the right. So these are all the operators which we use in Ruby program. We have seen some real examples. You can play around with it. You can use different numbers and practice and see the results. And if you have any problem or if something is not clear, then you can ask me in the comments. Thank you.